For us Tesla investors, what is it about the Cybertruck that was most important and most revolutionary? Was it the stainless steel exoskeleton, the new 4680 batteries, the massive gigacastings? No, those were not it. Our guest today will walk us through what he believes will be most impactful to Tesla and actually future revenue streams. He's going to review the new 48-volt architecture that will not only have a profound effect on the design and even functionality of all future trucks and cars, but will usher into the digital age of transport, and for us Tesla investors, the launch of Tesla licensing, this new technology to all automakers. In fact, Tesla already sent over the documents to everyone, and Jim Farley from Ford has responded. So today we've got Larry Goldberg with us. You can find him on X at Tesla Larry. He's a multi-entrepreneur and he's been joining me quite regularly. Welcome, Larry.
Thanks, Herbert. Lovely. It's really great to be here. I so enjoy it.
Wonderful for you to come because you often do these deep dives. You get very focused on a topic, you research everything about it, and you share it with us. And I appreciate this. This one is one of the bigger ones. You have been talking about licensing of all sorts of technology of Tesla to other car manufacturers, but you picked this one out, started talking about it earlier on. Tell us more about 48-volt battery or architecture.
Well, it's very important to understand the history here because the history really not only helps us understand how important the evolution is, but also gives us an insight into the supplier network and the whole idea of how the auto industry advances. And we've spoken about this on the channel before. I've talked about the supplier network and the potential role for Tesla in the supplier network because of how poorly the supply network really innovates. But we can start with, a brief history of the auto battery, and you'll see why this is so, meaningful to the history, to the story of the 48-volt battery, because you really have to go back to the beginning of the 20th century, actually the end of the 19th century, for the evolution of the battery. I mean, 110 years ago, you know, the auto battery was first put into the car because, a crankshaft. I don't know if you guys ever used a crankshaft car, but when
No.
I was a kid, my mom got a car that with a crankshaft on it. Had a starter motor, but had a crankshaft to back it up. It was a Citroen. We couldn't buy any of it. It was post-war, 1945 or 1946. She got the car. I was a kid. I was just born, but I remember that car when I was 8 years old. It was still in the family, and it had a crankshaft. But the crankshaft turned out to be a very difficult, as you can imagine, way to start a car. And in fact, it killed people because it would, bounce back, hit people in the head, and that was all she wrote. Well, you know, a brilliant engineer, Leland, who actually started Cadillac and ultimately sold Cadillac to General Motors, he saw this happen to one of his engineers, and then he tasked his leading engineer, Charles Kettering, to design a starter motor for the car, and that happened in 1909. And by 1912, the battery to power that starter motor had become standardized, and it was one of the first standards bodies in the auto industry. Well, that 12-volt battery sustained for many years, and it was only in 50s that we moved that 6-volt battery to 12-volt battery.
Mhm.
So you have to understand that we've been in this battery mode for 100 years, 110 years, and without very much advancement. But if you go to the next uh, slide, this kind of depicts the complexity of the electrical system today. Now you see the complexity of the wiring, just connecting the electrical components one to each other in a motor car. And all of that wiring is driven by what? A 12-volt power system and ultimately the 12-volt lead acid battery. So you can imagine from, you know, 1912 to 2022, we've expanded the use of electronics. We've expanded the use of electric. We have electrified the entire car to such an extent that there isn't a component of the car, whether it's turning up the windshield, whether it's adjusting the seats, whatever it is, we have absolutely electrified end to end that vehicle, some requiring a lot of power. And that's where the problem lies with a 12-volt system. So if you move to the next slide, you'll see that the future of low voltage architecture is very important, because look at the blue bars represent the amount of power being used by all vehicles, by all the components in the car. And look at the power being used in 1900, and look at where we get to by 1950 and 1960. Now, why is the amount of power being used important? Because the more power we need, the more resistance in the cables delivering that power. And it goes up by a factor of 4. The resulting amount of current being driven has risen immensely. By 1960s, we found it necessary to move from 6 volt to 12 volt. That was the revolution in 1960. And that halved the amount of power, the amount of amps we were driving through the car, because of that factor of what it requires to drive power to drive voltage through a cable, through a copper wire. Well, we made that change in 1960, but by the mid-70s, we were already exceeding the power that we were using in 1950. And so we started thinking about, how can we step the voltage up to reduce the amount of power we need in the car? And nothing happened. We kept on using that 12-volt battery. And so the amount of amps we needed to drive through the car just kept rising and rising and rising. And look where we are in 2015. We're at 250 amps being driven through the car. Why? Because the amount of wiring we needed, remember those wires that we had running all over the car, had, exploded. So we have to do something about it. And what's the obvious thing to do? Design a 48-volt system. Now, why 48 volt? 48 volt because above 50 volts, the electricity becomes dangerous to the human being. So we want to keep everything below 50 volts, and we want to get to 50 volts. So what the industry said is 48 volts is the ideal. Got it?
Mm-hmm.
Well, they said that 20 years ago. 20 years ago. Now, I don't know if you recall, but on this channel, we did a whole program about the supply network.
Supply chain, yeah.
The supply chain and the network of suppliers behind that.
Mm-hmm.
And that huge supplier network and those few OEMs just cannot bridge the gap between who's on first, who starts the process, who develops the process, who does the investment, who does the buying. And at this point, 20 years in, nobody has used the 48-volt system, and yet it is critical to moving the vehicle technology forward. And that's why before the Cybertruck was introduced, one of my biggest concerns was, are they going to go to the 48-volt system? I mean, they could have slapped that body, that amazing looking body, onto
mm-hmm.
a standard EV vehicle, just this kind of Model S with a skin on it. They didn't do that. They went to first principles and they said, we have to get to 48 volt. And we have to get rid of what? The lead acid battery. So we go to the next slide. We see exactly what all of this means. It means massive cables. And here's the problem with cables. Not only they get thick and heavy, but they all have to be put together by hand. Why? because every device needs a different connection to a different part that travels in a different direction across the car. Look at that cable. I mean, can you figure out how to debug that problem when there's a problem in the car? Where do you begin? Is it the wire? Is it the device? And if it's the wire, which wire? And is the wiring wrong or is the device wrong? It's impossible. Never mind the cost, because every one of these harnesses have to be done by hand. And they're very heavy. Copper is heavy, and they need immense amounts of copper. Remember, the more the current, the thicker the wire. The lower the voltage, the more the current, the thicker the wire. So something had to be done. And boy, was it done, and done in spades. And by the way, think about the battery. What is this picture about? This picture is about the recycling of the lead in the battery. You know, the battery manufacturers tout the fact that the lead in the battery is one of the most recycled commodities in the world. Yes, it's recycled, but look what it takes to recycle it. And here's the problem. There is no amount of lead in the human body that is safe. None. So what you're looking at is extreme danger for a huge number of people across the third and fourth world. So we have to get rid of, these lead acid batteries, and this is exactly what Tesla has been doing. So starting with the Y and now going back to the 3 and the S and X, they've replaced lead acid batteries with lithium-ion batteries. Lead acid batteries required 4 years replacement. Lithium-ion are kind of lifetime guaranteed. Lead acid batteries require tools to actually, tie connect the wires, the cables to the battery. The lithium-ion battery has got a toolless connection, saves a huge amount of problems, and is very safe. Can't connect the wrong lead to the wrong part of the battery, and I'm sure a lot of people understand just how bad that is. But that was kind of the first step, the baby step that Tesla took, along with several other baby steps in making this transition. But the huge step is integrating the 48-volt system, which no vendor has done yet, no OEM has done yet, no motor car company has done yet, and solve another huge problem. And in the next slide, you'll see how Tesla thinks about not just a part of the system or a system in the car, but all the systems in the car, the whole wiring problem, and the whole electronics problem. Look what they've done. If you look at the top left, you'll see an architectural diagram of what all the electronic components in the car look like in terms of how they join together. So you've got, whether it's the drivetrain, the instruments, the seats, the steering, the heating, the braking, the infotainment, however they're connected, they all connect one to the other, and then all to the generating system, and then there's electronic connections, and then there's electric connections. You've got to provide electricity to those components, and you've got to connect them electronically one to the other. And the result is this very complicated wiring diagram that you see, because on the diagram, it looks, pretty normal. It's, a few lines and it connects, but actually what has to happen is all of those connections have to run through the car and find a route one to the other. And that's what it ends up with, literally thousands of feet of wiring, all connected together in those cables. On the other hand, what Tesla has done is completely the opposite. Firstly, they've collapsed the wire into these very thin cables. Why? Because the voltage has gone up, so the current can come down, so that they can use thinner wires. Secondly, and this is the second part of their ingenuity, They've moved away from the way electronic components used to talk or do talk today in all other cars, how they talk to each other and how they talk to the computers. They use a bus system called a CAN bus. So that CAN bus is a bus that was created. It's called a controller area network. That's what CAN stands for. That controller area network bus was invented like 30 years ago by Bosch, licensed by Bosch, and it requires a wire for every single electronic component. It has to have its own component. It has to have its own wire to take the signal to it. Elon said, "This is crazy." Tesla said, I shouldn't say Elon said. Tesla said, "This is crazy. Let's just take Ethernet.
Yeah.
Like 30 times the speed of the best CAN bus system. And let's just connect all these components to one wire. And the same wire will carry the power." And so instead of this melange of cabling that requires this enormous expense that you see in what looks like a red car, but it's actually just the wires internal to the car. We see this diagram at the bottom left of just a single cable connecting all of these systems. And how can they do that? You see the architecture, vehicle as a one system. You have a central electronic control unit, a central computer, if you like, connected on a single bus that connects all of the so-called zone ECUs. And each of those zone ECUs control all the components within its zone. So whether it's a door, or it's the left side of the car, or whether it's the speaker system, in the roof of the car, it has a zonal connection for the whole roof or a zonal connection for the whole left door. And then all the components within that left door are connected to that zonal connection. The beauty of that is dramatic reduction in complexity. Very easy to, find and fix a problem, to determine whether it's the wire, whether it's the ECU, because all of that can be electronically tested before the car even leaves the factory, let alone before the car, and even in production. So if you think about the unboxed production system, you can test the zonal ECUs right within each quartile of the car. So, it takes this huge problem that is a really large proportion of the cost of the car and collapses it by what? Simplicity of architecture and, making the changes that need to be made without having to go through this dance of, well, is the supplier going to do it? Is the OEM going to do it? And relying upon the Robert Bosches of this world to come up with their solution, and then they own the software and you can't change the software. We've all seen those Ford, and we've played it on this channel. We've heard how, anyway, you understand that this is a sea change, a dramatic change in the whole approach to the design of a car. And that's why I was so excited and so anxious to see the implementation, not just of the 48-volt system, but everything that it represents. The standardization, to Ethernet, the combination of Ethernet with power, the zonal ECUs. Now, we've learned from Tesla, and actually I found this in the Investor Day presentation. The ECUs that Tesla use, about 90% of them are all programmed by Tesla. This compares to approximately zero for all other car manufacturers. So Tesla doesn't have to depend upon any supplier to do any coding or any debugging or any updates or any changes or improvements to the electronic control units of their components. They can do it themselves, and they can do it by software on over-the-air updates. That, by the way, is one of the big problems of over-the-air updates for the other vendors. They don't program their own ECUs. 80%, 90% of the ECUs are supplier-based, therefore they can't be updated by over-the-air updates. So you get an idea of the importance of this dramatic change in how Tesla have approached it. And what does it mean? I don't know if you recall our supplier conversation and how I said that Tesla are going to be, in the licensing business. They're going to be suppliers. They're going to be tier 0.5 suppliers to the auto industry. Well, we don't have to follow the breadcrumbs any further. Let's just see what's happening. So if we go to the next and the final slide, and we see that, firstly, I featured two people here. The one is this trolling that apparently, and it's a little bit of a joke. This is not the real book, but this is the book that Elon is supposedly to have sent to CEOs of all the OEMs. That is entitled "How to Design a 48-Volt Vehicle." And there's a signature of Elon's at the bottom, and it says, with love from Elon. But it apparently, and we've heard directly now, from the CEO of Ford, that he did get that document, and it didn't have little trolling cover to it, but it was a document that Tesla sent to everybody and gave them best practices of how Tesla have implemented the 48-volt system. And taking the breadcrumb trail a little bit further, here is a time cover from just this week where Time awarded Tesla's Becky Tanucci, a Climate 100 list, a member of the Climate 100 list. Now, who's Becky Tanucci? She is the lead for Tesla's charging network, supercharger network. And she's the one that negotiated the deals with Ford, GM, and all the other OEMs to standardize on the NACS adapter, the supercharger adapter. So that's the pattern. And finally, the last little breadcrumb I'll give you is that at the Investor Day presentation, Pete Bannon, who's the Tesla director responsible for the electronic architecture, actually ended his presentation with these words, that we invite other OEMs and the entire supplier network to join us in this evolution. So putting that together, I think the next big deal is Ford announcing that it's adopting the Tesla architecture. And I think that there will be an agreement between Tesla and Ford. I'm hoping there will be an agreement for Ford's sake, where Tesla will sign up to supply technical support and components and software support to implement the 48-volt system for Ford.
Yeah,
and that'll be the beginning of many other agreements of the same nature.
Yeah. It's going to be a new licensing agreement between OEMs, Legacy Auto, with Tesla for the 48-volt. They're trying to get them to move to this way, and they've given them the steps that they took. But it's a Herculean effort for these OEMs to try to change their model to this new model, but they're going to have to license it from Tesla probably. It's going to be the easiest for them. I want to share this that just happened this morning. So Jim Farley, CEO of Ford, came back and said they weren't joking. We received the document today, dated December 5th. Thanks, Elon. Great for the industry. And then Elon replied, "You're welcome." And by the way, Elon and Jim, they've been liking each other. X's. So, maybe I'm reading too much into it, but it sounds like, again, just like what happened, Ford was the first to announce a partnership for supercharger with Tesla. They're going to do this again. So let me just repeat what you've said here, which is, for folks who may not be following and understanding the significance of 48-volt architecture. So what this allowed to do, instead of all those wires that are all over the place, people can understand that quickly, but that requires you to build the car kind of like the way they do it now, which is, the whole car, and then because the wires kind of go longitudinally and all over the place. So you need to, make sure the wires go all over the place. With this new model, you can basically build unbox model, just corners of the car or the back first and the front first, and they plug in like a Lego. But now it's a digital car, right? You can control everything, the the mirrors, the windows, the speakers, anything, the seats, all through the same wire, which because it's Ethernet, it not only provides power, but it provides digital control. And that allows you to control the brakes. First of all, the steer by wire, which is what the Cybertruck does, is being done now through the software instead of having an actual physical connection to it. And then same thing now with if they launch the brake by wire, the brakes, which is the 4 brakes, need pneumatic tubes to control those. If you don't need that anymore and you've got just the digital control, you can just plug and play the corners and put it all together. So this is a brand new way to build. But the big thing you're talking about is licensing, and it sure looks like it's very likely it's going to happen.
Yeah, I mean, there are so many, evolutions and that can arise from this change to this EE architecture, electronic electrical architecture. This EE architecture it unleashes an enormous amount of energy. It brings the motor car into the digital world. That Tesla have taken multiple steps to bring the motor car into the digital world, but this really is the next level. And as you say, steer by wire is a natural, result of this, is the natural beneficiary of this. Steer by wire is very difficult without this. But going far beyond steer by wire into areas that, it's very difficult to even contemplate. So particularly in the robotaxi world, the car is going to have to become far more digital than it is even now, even for Tesla now. And when you think about the over-the-air updates that Tesla can perform, other cars are now getting over-the-air updates, but what can they update? Very little. Why? Because they don't have an EE architecture that allows them to go out and make a change to, the windows, make a change to, so many aspects of the car that you wouldn't even think about. Think about, I don't know, the sound system, adjusting, the output of a particular pair of speakers in the balance, in the audio balance, fixing the audio balance, giving some kind of, acoustic feedback for a given speed and so on and so forth. I mean, there's endless capability now because of this EE architecture that no other vendor can begin to, no other auto company can begin to equal.
Yeah, Jim Farley was of CEO of Ford was on an interview 3 months ago, and he said that there's 200 software vendors or vendors that they have to work with to control the software that they're for the cars. And he gave the example that if I just wanted to make a small change to the way the car seats, how you decide to make the car seats move forward or backwards and maneuver it, he needs to talk to Bosch and have them make those changes. And so,
he said it takes months, if not years, to get that change made, if they are prepared to make the change.
Right, because it's up to them, because it's based on their time frame of what they want to do and how they want to move forward.
And what they're going to do is they're going to go back to all their other OEMs and say, we propose this change and get that feedback. And so that's how it goes.
Yeah.
In this EE architecture, all of that will be in Ford's hands and Ford's hands entirely.
This is wonderful. Okay, so two big news. First of all, you've pointed out 48-volt architecture is likely the most important technological advancement. There's so many. It's really the inside of the Cybertruck is marvelous. But this was a big one. And it allows Tesla to do the unbox model, which then opens it up to not just one kind of vehicle, but multiple different vehicles. But it's just plug and play. Just connect them all together, controls the software. And then the big thing you've been saying for quite a bit is licensing. You've been forecasting that there's going to be more licensing with many of these OEMs. This is an example of another one. Supercharger was first, 48 volt probably is next, which just comes with software. That could be the next thing. Makes sense.
And we must also understand that this is going to be several points of gross margin.
Yeah, it's all software. It's all margin.
Copper is heavy, needs more battery. Copper is expensive, and building that wiring harness is very expensive. Most of that goes away. So there's a huge value add, huge value add. And then, Tesla, the ECUs, each controller for each function, for every connected item in that car, and we've been through a litany of a few of them, have to be programmed. Right now, Tesla up to almost 90%, over 90% of ECUs being programmed by themselves in the Cybertruck. In the next gen vehicle, it'll be 100%. And Tesla's shown that they can go back and refresh all of these previous vehicles of theirs and upgrade them to the standards of today. So we will see improvements in the Y, the 3, the X, and the S over time.
Wonderful. Thank you so much, Larry. You should follow him on X. For every one of these things that we present, he'd actually done a full deep dive, and he does these posts on X, and you can see his thinking and his analysis, and you always come with numbers. Appreciate you, Larry. Thanks, everybody.
Thank you, Evan.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.